Good morning. We will start session 6 on chapter triangles, and this is the last session of this chapter. This exercise is about inequalities. Now what is this inequalities? Suppose we have a triangle, say A, B, C. Okay. Now just let me name the angles of a triangle. Let us assume that this is 80 degree and this is total. Sum of the angles has to be always 180. So I will assume that this is 30 degree, or okay, we will take that as this is 40 degree. So how much? 80, 40 will give you 120. Remaining is what? 60. So this is a triangle, right? 40 degree, 80 degree and 60 degree. Now based on the angles, I can tell that in the given triangle, which is the longer side. So the angle, which is the greatest angle here, 80 degree. So the angle opposite or the side opposite to the greatest angle is the longest side. That means AC is the longest side or greatest side, right? I have no measure of AC. Then comes what? So I can say AC is greater than AB is greater than BC. So BC is the smallest side and AC is the longest side. How did I come to know this? We got to know based on the angles given. We have a right angle triangle. How do we say that hypotenuse is always the greatest or the longest side of a right angle triangle, right? We know that. Why? That's only because now this is 90 degree. What should be sum of this? Either it has to be 45, 45 or it can be 60 and 30, right? But it cannot be greater than 90. So what has to be the greatest side? That is hypotenuse. So the side opposite to the greatest angle is the longest side. Now this is what we are going to deal with in numericals here, which is called as inequalities in the triangle. So there are some small riders or something given in worked examples. We will directly move on to the exercise, a very small exercise of 5 sums. After this you also have an optional exercise, but that exercise is not from examination point of view. Some of the sums are like you have to make a plot design where you have to mark the things. So that exercise will not be done. So these exercises are not from examination's point of view. So this inequalities exercise will be the last session or the last exercise from this triangles session. We'll quickly begin with an exercise now. The only thing you should know this concept. So wherever is the greatest angle, that is the longest side or the greatest side. So quickly we'll begin with the sums. There are some methods I can tell you here is, sometimes the method might change because it is proving. So this proving can be done in very 1 or 2 steps or 3 or 4 steps extra. But the ultimate thing at the end is we are going to get the same answer. Exercise first one, show that in a right angle triangle. So let's draw, figure is not given. Show that in a right angle triangle, hypotenuse is the longest side. We need to show, we know that it is the longest side, but we have to prove it. So let us mark given in right angled triangle ABC at in right angle triangle ABC, you can simply say angle B is equal to 90 degree. That's all. What we have to prove? To prove hypotenuse that is AC is the longest side, right? Proof. Okay. So I will say that in triangle ABC, angle A plus angle B plus angle C is equal to, sorry, 180 degree. Reason? Angle sum property. So, what is angle B? Angle A plus angle C plus 90 degree is equal to 180. If 90, if I transpose this side, angle A plus angle C is equal to 90 degree. Right? Until this it is very clear. I just transpose this 90 to this side. Now, what is this 90 degree? 90 degree is nothing but angle B. This implies angle A plus angle B, plus angle C is equal to angle B, because angle B is equal to 90 degree. This tells us that if I want angle B, I have to take the sum of angle A and angle C, right? Alone angle C will not be equal to B. Sum of this will be equal to angle B. That means whatever I add, this is the greatest one. Only then I can add the two smaller angle to get a bigger angle, right? Till this point is very clear. Okay. Now let's write the next part. This implies, what I can say here is, angle A is less than angle B and angle C is less than angle B. Correct, no? See, if it is 90, it should be 30 plus 60 or 60 plus 30 or 45 plus 45. Less than angle B only. That is what I have written. Angle A is less than angle B and angle C is less than angle B. Sometimes in your school, they will choose in other way. Angle B is greater than angle A. Angle A. Both are same. Less than or equal to C for which angle they are using correctly. With respect to angle A, what is the side? BC. BC is greater than, what is the sign for angle B? AC. And for angle C it is AB is less than AC. What reason will you write here? Now what we have used, sides opposite to equal angles, or sides opposite to greater angles are greater, or the sides opposite to greater angles are longer. That also you can write, or you can just leave it. It's okay. We have done, this side is greater than this side is also greater. Therefore, hypotenuse AC is the longest side. Sides opposite to greater angle is greater. You can just write here, children, if you want the reason. Okay. Now is this very clear? That is how we proved it. Now let's see similarly the next one. The next few questions are given. It's all about proving the greater or lesser, or the sides that is smaller or greater. We need to do it. In figure, the sides AB and AC of a triangle are extended to points P and Q respectively. So this is the given triangle. This is A, this is P, this is P, this is Q, and this is C. So given in triangle ABC, and write the same thing. Points in triangle ABC, AB and AC are extended to points P and Q respectively. What we have to prove here? Yeah, also they have given us something. Let us also write that. Angle PBC, this angle is less than angle QCB. How? It's given. Let us accept it. What is there in the given? What we have to prove now? We have to prove that or show that AC is greater than AB. AC is greater than AB. Now here no sides are given, no angles are usually given, but still we have to do it. Let's start. Proof. So in proof, now what I will do here is, let us go with let us take this triangle. In triangle ABC, can I tell angle PBC is equal to, that is this angle is equal to, suppose just imagine this is an exterior angle, this is equal to sum of this and this. Okay, PBC is equal to angle A plus angle ACB. Exterior angle theorem, equation 1. Next, what I will write here is, I will take this side of a triangle. So angle, how do we read that? QCB. Now if this is a triangle and this is the exterior angle, it is sum of this and this. So again it is angle A plus angle ABC. Exterior angle theorem. Okay. Now what they have given here, we know that PBC is less than angle QCB, right? Given. What is PBC? It is angle A plus angle ACB, right? Less than as it is. What is QCB? Angle A plus angle ABC. I have just substituted what it is. So I can say A and A will get cancelled. See, greater than sign we can't transpose, but the same thing it is. What left here? Angle ACB is less than angle ABC. For ACB, which is the opposite side, it is AB. Less than ABC, it is AC. Now, what reason will you write here? What you have written earlier. Sides opposite to greater angle are longer. Sides opposite to greater angle are longer. Same thing. Whatever angle we have written, for that same reason. What is there? AC is greater than AB. What did we get? We got the same thing. See here, you see AC is only greater. Reverse it and write. AC should have greater sign only. Huh? See here, it's a greater sign. It's a greater sign. AB should have lesser sign. It's a lesser sign only. That is what they had asked to prove, and that is what we have proved it. Quickly, we'll start with the next one. So in figure, third one, given angle B is less than angle A and angle C is less than angle D. Show that. Let us first draw. So this is D, this is A, this is this is B and this is C. To prove AD is smaller than BC, right? So now this is very simple. We have to just take what is given and write with respect to it. Proof. Angle B is less than angle A. So angle B is this, angle A is this. With respect to angle B, children, what is the side? It is OA. Okay. Then next is what? With respect to angle A, what is the side? It is less than OD. sorry, OB. This will I will write neatly once again because it is looking different. It is OB. Now keep this as it is. We want AD, that is the whole line we want here. Okay, keep that as it is. Equation 1. OA and OB, we got it here. Next, what we have? Angle C is less than angle D given. Angle C, what is the side? Angle C, I'll mark here. And angle D. Angle C, the side is, you have to write reason here, huh? Sides opposite to greater angle or sides opposite to angles are equal. That reason has to be written always. For C, which is the, this is C and this is the side, it is OD. Less than. For D, which is the side, it is OC. Equation 2. Add 1 and 2. OA plus OD, same sign, OB plus OC. OA and OD will give you what? AD. OB and OC will give you what? BC. That is what we proved it. Fourth one. So they have given a kind of a trapezium. So this is A, B, C and D. AB and CD, so can I tell, it's not a trapezium also mentioned, it is in quadrilateral. So given in quadrilateral, ABCD. AB is the smallest side they have given, and which is CD is the longest side. Okay, what we have to prove? We have to prove first part, angle A greater than angle C, and second part, angle B greater than angle D. Children, this is homework. Which one? Second part is homework. I'll solve first part. For second part, you have to rewrite it once again and do it, right? For this we have construction, because we are solving the first part, construction. For first part only. Since I am solving first part, construction for first part I will give that. Join AC. Let us assume that there is one imaginary line AC here. So that inequalities we want a triangle there. Same like in congruency how we require a triangle, here also I require a triangle. Join AC. So since I have joined AC, proof in triangle ABC. Okay. When we talk about this triangle, let us assume that we won't have AC. It is just our assumption that we have joined AC, but AC does not exist actually. Okay. So if I consider a triangle ABC, can I say AB is lesser than BC? Why? Because AB is the smallest side, and of course, with compared to BC, AB will be smallest only, right? Because they have given reason. AB is the smallest side. Okay, we will write this as BC is greater than AB. Doesn't matter, both are same. Okay, you have written, write the angles. For BC, what is the angle, children? Angle BAC. For AB, what is the angle? Angle ACB. Equation 1. Reason. What will you write? Sides opposite to greater angle are longer. Sides opposite to greater angle are longer. That is the same reason what you have to write. Okay, this is done. Let's go for another triangle now. In triangle ADC, according to them, CD is the greatest side. CD is greater than, let us assume there is no AC, then it will be AD. Reason, CD is the, what is it, longest side. With respect to CD, what is the angle? So CD is the side, angle is CAD. For AD, it is ACD. Equation 2. Sides opposite to greater angle are longer. Add equations 1 and 2. BAC plus CAD. Is greater than ACB plus ACD. BAC plus CAD. BAC plus CAD is whole angle A greater than ACB is this angle plus ACD is whole angle this angle C. Hence proved, right? So if I have to talk about angle B greater than angle D, construction what should I give? Joint BD. So what you all will do now is, first you all will write down this. Again, construction, second one, joint BD. At that time AC will not be there. Similarly, you will start, and that's your homework for today. So the last sum of today's session and the exercise and the chapter. So P, Q, R. So PS bisects angle QPR. So this is a bisector. Okay. Given fifth one, in triangle PQR, PS bisects angle QPR. That is, angle QPS is equal to angle RPS. Okay, these two are equal. To prove equal to, we'll write this as Y or X. Y you will understand later. Why did we choose a variable? To prove angle PSR is greater than angle PSQ. PSR is greater than PSQ. These two. Some way greater or lesser they will give us. Proof. So first of all what we will write here is, now let us first assume that anything else they have given. Oh yeah, we forgot to write one main thing. They have given PR is greater than PQ. Let us first mention that. So proof. PR is greater than PQ given. Where is PR? PR is greater than PQ. With respect to PR, what is the angle, children? Angle PQR is greater than PQ. Angle PRQ. This can also be written as angle PQR. Till here if I take, angle PQS is greater than PRS. Reason, if you write about sides and angles, now you know what to write. There we wrote sides opposite to greater angle, angles opposite to greater side are greater. Write that reason. Keep this as it is, right? Let's choose. In triangle PQS, so this becomes the exterior angle. Angle PSR is equal to, this angle is equal to sum of this and sum of this, right? Is equal to angle PQS plus this. What is this angle, children? Here we have considered them as Y. Both are equal. That is why I will write off Y. It will become easy. Exterior angle theorem. Equation 1. Similarly, other side of triangle. In triangle PSR, angle PSQ is equal to PSQ is equal to sum of this and this is equal to PRS plus Y. Exterior angle theorem. Equation 2. Right? So anything else till here it is very clear. So this plus this is equal to exterior angle theorem, what we have written here. Now let us write from the given part what we have assumed here is angle PQS is greater than angle PRS. Let us write down that. We know that angle PQS is greater than angle, where is it? Angle PQS is greater than angle PRS, right? So, right? See, PQS is not given. PQR is greater than PRQ is given. But how did we write PQR as? PQR, I wrote it as PQS till here. PRQ. PRQ, I wrote this as PRS till here, right? Now, let us add equals on both sides. Angle PQS plus Y. Which are the equals? Are these two bisectors? Yes. Is greater than angle PRS plus Y. Axiom 2. When equals are added to equals, that's all. The remainders are not equal, we are not forming any angle, but true, yes. We are adding something equals on both the sides. Did we see this equation somewhere? PQS plus Y, where it is? PQS plus Y, what it is? Angle PRS. Angle PRS greater than PRS plus Y, PRS plus Y, angle PSQ. From equation 1 and 2. That is what we required here. Angle PSR, angle PRS or angle PSR. Let me just check. PSR is equal to and PSQ. Let me just once again, children, I wrote the angle wrong. So it is PSR, not PRS. PQS plus Y. PQS plus Y is PRS. So many PQ, PR. So then I got confused with that. So PSR. See here. PQS plus Y is PSR. That is what I have written. That is what we proved. Angle PSR is greater than angle PSQ. Hence proved. Right? Quite a complicated inequality where we had to prove this. So this is how you prove this. Wherever reasons angles opposite to or sides opposite to greater angle are greater, that you need to write it correctly. With this we complete this exercise, and with this we complete this chapter triangles. So the main thing what you should know in this chapter is criteria for congruency and worked examples. Work on them. You all have written the test. Most of you have done really well. Some of you have got less, so never get disheartened. The only thing what comes to a conclusion here is you have to practice well so that you can perform well. it will take another 2 day or 2 time for me to go through all your answer sheets, what you have written, and give feedback either by call or by message to tell that how you have written and how you can improve. So till then,